Okay, so let's do practice test 2, number 2. It says use the Lagrange multipliers to find all extrema of the function subject to the constraint. So our function here is the same as the one from actually question 1 on the practice test, but we have a constraint here. So you might ask yourself, well, shouldn't the answer for this one be the same as it was for question 1? And the answer is no, because in question 1, so let's suppose this bowl here is our f function up here, and the whiteboard down here is the xy plane. So in question number 1, we're finding all relative extrema and saddle points. So looking at this bowl, you'd have a relative extrema up in this region here. Okay, so that would be your answer for number 1, say. But in this question, we have a constraint. So this constraint's an ellipse, but just suppose it's some sort of a circle here. So it's in the xy plane. So now, imagine now I bring my surface over this circle. So then just imagine walking around the circle and looking at the surface above you, and you're looking for the highest points. So if I went like this, went over it, and drew, what I get be something up here, say like that, projecting the circle up to the surface. So in that case, this would be the max here. So that'd be the max. You have a min down here. So that'd be the answers then we'd be finding for this question. So you can see they're different than the relative max of the surface and the saddle points. Okay, so let's keep going. Okay, so let's keep going here. So we have to find the partial derivatives then for Lagrange multipliers, step 1. So let's first find fx. And I'm calling the constraint guy here, this part g. So partial f respect to x will be gone. It'll be 2xy. And then it'll be minus 2x. Okay, fy. So this will be 3y squared. That'd be x squared. Derivative of x would be gone, and derivative of negative 5y would be negative 5. Okay, g partial derivative with respect to x. So the 2 would come in front and cross off of this one, just become x. And gy would be 2y. Okay, so now we can write our system. So we need to solve system. So our system is going to be fx, so it's going to be 2xy minus 2x equals lambda times g of x, which is x. We'll call it equation 1. We'll have fy, so it's going to be 3y squared plus x squared minus 5 equals lambda times g of y, which is 2y. That's equation 2. And our third equation is just our constraint, this guy over here. So it'll be x squared over 2 plus y squared equals 2. That's our third equation. So this is our system of equations here. So note here, if x not equal to 0, then dividing equation 1 by x, we get, so dividing everything by x, that'll be gone, to be 2y minus 2 equals lambda. Okay. Now let's plug our lambda now into equation 2. So this guy, the 2y minus 2 can go in place of lambda here. So doing that, we'll get then, so 3y squared plus x squared minus 5 equals, so in place of lambda we're going to write 2y minus 2 times 2y. Okay, so let's multiply. So multiplying this in, say it'll be 3y squared plus x squared minus 5. So multiplying this in will be 4y squared minus 4y. And then solving for x, so solve for x squared, sorry. So solving for x squared, so moving the 5 over here and subtracting 3y squared on both sides, we'll get x squared equals, so subtracting here would be y squared minus 4y, adding 5 to both sides, plus 5. Okay, so now we're going to substitute this guy now, so this is going to go in place of x squared right here. Okay, so let's keep going. Okay, so making that substitution, we'll have then, so in place of x squared, we're going to write this guy, we're going to be then y squared minus 4y plus 5 over 2, because that's my x squared, this guy, plus y squared equals 2. So now we're going to multiply both sides by 2. So multiply by 2. So multiplying everything by 2 here, the 2's are cancelled there, so you'll be left with then, bring it up here, y squared minus 4y plus 5, multiplying this by 2, plus 2y squared equals, multiplying this by 2, 4. So we get to here, then moving things around, moving a 4 across, we'll have then, and combining those, we'll have then 3y squared minus 4y, so subtract 4, and so the plus 1 in here equals 0. And you could use a quadratic formula, or you could note actually that factors, so factoring it, so it factors as 3y minus 1 times y minus 1 equals 0. So we're going to get two answers here. So you have 3y minus 1 is 0, or y minus 1 is 0. So solving the first one, adding 1 dividing by 3, we'll get y is equal to 1/3. Or adding 1 to both sides, y equals 1. We just box those for now. Okay. I want to write some stuff, but I want to keep this x squared thing, so we write it here, or x squared equals y squared minus 4y plus 5. Let's call this star. Okay, I want to erase this stuff now. So now plug y1 into star. We get, so bring it up here. So putting 1 in place of y here, we'll get x squared equals 1 minus 4 plus 5, so that's 2. So then taking square root, we'll get that x is plus or minus square root of 2. Now, next, plug y equal 1/3 into star, we'll get an x squared equals, so 1/3, so it'll be 1/3 squared right here minus 4 times a third plus 5, so then the x squared equals 1/9 minus 4/3 plus 5. You get a common denominator, which is going to be 9. Okay, so changing everything to 9, so it'll be 1, it'll be minus 4 times 3 plus 5 times 9 over 9. What you can check is 34 over 9. So taking square root then, x will be then plus or minus square root of 34 over square root of 9. So it'll be plus or minus square root of 34 over 3. Okay, so let's summarize what we have. So summarizing, we found solutions then are plus or minus square root of 2 comma 1 and plus or minus square root of 34 over 3 comma 1 comma 1/3, sorry, here on this one. Now when we solved the system, we assumed in equation 1 here that x was not equal to 0. So let's see what happens when x is 0. So if x is 0 in system, then if you put 0 in the first equation, it would be 0 equals 0, which would be fine. Then by equation 3, we have then if you put a 0 in place of x here, you have then y squared equals 2. So then y would equal plus or minus 2. And if you put 0 into equation 2, since you have freedom over the lambda here, you can make it work. So pretty much another solution then I can add to my solutions up here would be when x is 0, then what you're showing we have plus or minus square root of 2. So if you count how many solutions we have, there's actually 2 here, go plus or minus, so 2, 4, there's actually 6 solutions. So now let's figure out which one's the max and which ones are the mins. So let me erase some stuff here now. So let's look at f of plus or minus square root of 2, 1 first. So I'm going out to my f function. In place of x, I'm putting plus or minus square root of 2 and 1. I'm going to be actually doing both at the same time here. You'll see why in a second here. So y is 1, so it'll be 1 cubed plus x squared. X now is plus or minus square root of 2 times y times 1 minus x squared will be plus or minus square root of 2 squared minus 5 times 1 plus 1. So you can see then, oh sorry, it should be a square in this one because it's x squared y. So when you square this, the plus and minus goes away, and this one also, so it's going to end up being then, so here, be 1, and it's going to get a 2 there, so be plus 2, and squaring that will be minus 2, minus 5, plus 1, so they cancel, Looks like it's going to be -3 for this guy. Okay, so let's do the next ones. So doing this guy next, I'll let you check. I won't work it out here, but you just put this in place of x, put this in place of y up here. You'll end up with a negative 85 over 27, and that's roughly equal to, you do a decimal approximation, negative 3.15, so negative 3.15. Okay, next we'll do these ones. So when you do the other two, when you do f of 0 square root of 2, so it'll be 0 for x, square root of 2 for y, up into your function up here. I'll let you check it's 1 minus 3 square root of 2, which is roughly negative 3.24. And when you do 0 for x, negative square root of 2 for y up here, you'll end up with this guy, which is 5.24. So this guy, looking at our values here, we got -3, this, and this. This is the biggest, so it's going to be a max for sure here. So max there, and this guy is the smallest, so there's going to be a min on this guy. But the other ones were is not, so it's actually the other 4, because there's plus and minus here, is not clear what they are. That one could be a max or a min or vice versa. So let me draw a little picture so we can figure it out. Okay, so f of plus or minus square root of 2 comma 1 is a z-value. So all of these guys are all z-values. So I put the z-values over here on the z-axis. And so let's do a little graph here. So we know the 5.24 we already established, that's a max. So it's going to go like that here. And negative 3.24 is a min. So let's say it's here. Now, the question is, negative 3.15, is that a max or a min? Well, suppose it was a, so suppose this guy went up to negative 3.15 and it turned around. Have to go on both sides. Because there's two of them, because the negative 3.15 came from a plus and minus part, so there's actually two values there. But I have to come up and turn around here and here. But if it did that, it would create another minimum down here, but there is no other minimum, so therefore it could not go like that here. So it's going to actually have to go up to the -3 part. Say go across here, a -3. This guy's going to have to go up to the -3, and it's going to have to come back down again to 3.15 here on either side. And then it's going to have to go up to this guy, and this guy's going to have to come down over here. And it's going to wind around like this. I'm going to put a dot here and a dot here. So it looks like the negative 3.15 is a min. So this guy's a min. And the -3 looks like it's going to be a max, so this guy's going to be a max up here. Okay, so let me explain this a bit more. Because this is actually on our constraint here, and our constraint was the ellipse, so it would be something like that, say. So imagine wrapping this around the ellipse, and you'd have to connect these 2 points. So 2 dots connect. So 2 dots connect. Because you'd take this graph and you'd put it around our ellipse and you connect these two together. So it'd be like a roller coaster going around above the ellipse. So we're done.